So Newton's second law is simply that force equals mass times acceleration. Everybody unconsciously knows second law. Everyone knows that the heavier objects require more force to move than the same distance, or move the same distance, as lighter objects. In other words, here this little test tube critter again kicks a wall, says ouch, and this test tube critter down here kicks a soccer ball, and all of a sudden that equals fun. Fun, ouch. Essentially, more mass means more force needed to accelerate it, says the bald guy with the crustache. So most simply put, F equals ma. However, the second law gives us an exact relationship between a force, a mass, and acceleration. It can be expressed as a mathematical equation. F equals ma, or force equals mass times acceleration. So let's solve a problem to make a little bit more sense of Newton's second law. So if you get a calculator handy, we'll do. So this is an example of how Newton's second law works. So I've got this car. It is important to make an observation of what you have. I always say that if you know what information you have, you should be able to identify what equation you're going to use to solve. So here it's asking question mark Newton, and Newton is a measure of force. So I know I'm solving for F. So F equals mass of 1,000 kilograms times A, or acceleration, of 0.05 meters per second, or 0.05 meters per second squared. So Mike's car, which weighs 1,000 kilograms, technically 1,000 kilograms is a mass, so I don't know why it says weighs here. Weight is a force, mass is in kilograms. His car is out of gas. Mike is trying to push the car to a gas station, and he makes the car go to 0.05 meters per second squared, or meters per second. Using Newton's second law, you can compute how much force Mike is applying to the car. So let's solve this. F equals 1,000 kilograms times 0.05 meters per second squared, and the final answer would be 50 newtons. It would be 50 newtons of force that Mike is applying to the car, this 1,000 kilogram car, to make it accelerate at 0.05 meters per second.